Good day, all. You're welcome once again to Just Me Computer Tutor. I will be treating data science overview. And in this lesson, what do we expect? We're expected to learn what data science is, what is data science, the essential data science skills, the skills you need if you want to be a data scientist, the careers you can pick up in data science, the key data science terminologies that you need to know, the data science processes and the required tools. So these 5 things are all that we'll be learning today. And I urge you to continue. So what is data science? Actually, data science is an interdisciplinary field that combines programming, statistics, and every other field that involves programming and statistics. So, however, whichever professional you are, you don't need to change from your field. You can be a data scientist in your field. The medical practitioners, if you're a medical practitioner, you can be a data scientist. Whatever you are practicing, an engineer, you can be a data scientist. So data science is an interdisciplinary field that combines programming, statistics, and domain expertise to extract valuable insights from data. What is done in data science is that you extract valuable insights from data. So why is it important that we are learning about data science? Why is it important for us to learn about data science? We're actually living in a data-driven world, and it is important we learn about data science. Everywhere we go today, we hear about data. When you get to bank, you hear data. Please let me access your data. You go to the airport, you want to make bookings. So we need to learn about data because today's world that we are today, it's driven by data. And so we wouldn't want to be naive. Even if you don't want to practice data science as a career, you should not be naive. You should have some knowledge about data science. So it is important to learn about data science. Next, we'll be going to data science essential skills. What are the essential skills that you need to have as a data science? Number one, I didn't arrange it as in form of hierarchy, no, or in the order of importance, no. But I'll just be picking up the skills one after the other. Programming. It's a fundamental skill that a data scientist should have, though it is not everyone that practice data science that have programming skills. However, for those who will practice in the aspect of ML, machine learning, they need programming skills. So when we get to careers in data science, you will actually know what skill in data science you need to acquire. Then the next skill you need is statistics and probability skills. You have to be skillful in statistics. You need to understand the underlying principles behind statistics and probability to practice well in data science. For example, you don't know what mean is, and you want to do a descriptive statistics, or you don't know mean. That mean is the same as an average or median. Then how do you operate in that field? No. So you actually need some statistics skills to operate as a data scientist. The next skill you need is data wrangling and preprocessing skill. Data wrangling involves cleaning, transforming, and preparing raw data for analysis. You must have these skills because you are not always assured that the data you will have at hand to work with are all clean. Data can be incomplete, can be messy, that is full of wrong. Some might be having wrong information. Some might have incomplete data. That is, you will have, for example, you want to get data of some secondary school students, their name, involving their name, their parents' email address, probably their address, home address, and then class that they are, their class. And so you can have some who will fill all. You can have some who will just fill 3 columns. Some will leave out the class they are. That is how sometimes you get data. So you need the skill to arrange and prepare your raw data for analysis. That's data wrangling and preprocessing skill. You also need the machine learning skill. Machine learning is a key component of data science, and it is on this principle that artificial intelligent machines operate. So you need to have various knowledge of, need to have knowledge of various machine learning algorithms so that you can perform well as a data scientist. And lastly, you need to have data visualization skill. What is data visualization? It's the art of presenting data in visually engaging and easily understandable manner. So, yes, after you must have done your analysis, a layman needs to understand what is the result of your analysis. So presenting the result of your analysis in such a way that anyone, whether the person is statistically oriented or not, can look at the results and then interpret and understand and make decisions with it, informed decisions with it. So this skill is called data visualization skill. And in data visualization, we do line charts, plotter, scatter plots, a lot of charts are involved in data visualization. So that's the last skill that you actually need. And that's second to the last, not last. And finally, what other skill do you need? You need to have a domain knowledge. What do they mean? In the field you want to practice, is it in education? Is it in health? Or whichever field, engineering, sciences, you need to have an understanding of that domain. It will help you to interpret the data better. So you see now that I said earlier that even if you are a medical doctor, yes, you can still operate as a data scientist. So what are the careers in data science? What are the careers in data science? We have data architect. Who is a data architect? Data architect is a person who builds database from the scratch, decides how the data will be retrieved, processed, and consumed. So such a person is a data architect. The same way an architect will design how a building will be laid on a plot of land, how it will be. So that is the same assignment that a data architect has. He builds the database from the scratch. He designs how the data will be retrieved, the data will be retrieved, processed, and processed. Now, a data engineer is the person who obtains data and makes it ready for analysis. This data engineer picks up the data from the database that is being designed by data architects and then obtain the data and makes it ready for analysis, meaning you remember data cleaning, data wrangling. So it does data cleaning. You see now. And database administrator manages the control of data in and out of the database. This is a person who manages the control of data. And usually they work on traditional data. Later, you will know what a traditional data is. Business intelligence analyst, he analyzes past historical data. Business intelligence consultant is a business intelligence analyst who is contracted, who is only contracted when service is needed. Well, such a person may have a broader experience than a business intelligence analyst because he's working in different domain. Business intelligence developer, BI developer, uses vast programming languages. You see now, this person needs a programming skill like SQL, Python to perform analysis specifically designed for the company. Then a data scientist, who is a data scientist, a data scientist uses both traditional statistical method and the unconventional learning and machine learning techniques to make predictions. A data scientist make predictions by using the statistical methods or data and machine learning techniques. So it makes decision. Who is a data analyst? The person performs the duty of a data scientist. In addition to making predictions, he also performs advanced analysis. So who is an ML engineer, machine learning engineer? Such a person uses computational models developed in machine learning to solve complex data science and business tasks. So these are the careers in data science. Now, data science, key data science terminologies. We'll be learning about the terminologies in data science. You have heard me saying traditional data. What's a traditional data? Structured relational data organizations stored, that are being processed, is stored, is processed for a period of time. But the most important keyword is that it's a structured relational data. A data that has its fields related to each other. Somebody's surname is related to the person's address. It doesn't mean the person's surname is on the address, no. I gave an example of information of senior secondary school students, which has the information of their surname, their other name, their home address, parents or personal phone number, parents' email, and their classes. So that person's name is having a relationship with the class. So it's a relational data, a structured data, well-structured data. And usually it has been stored for some time. So like an example is customer information that is being collected in the bank, the national identity, data from organizations' annual research inventories. All these are traditional data. So the next type of data we'll be talking about is big data. Big data refers to extremely large data sets that are challenging to process and analyze. There are three V's, three keywords that makes a data a big data. Number one is the volume. It has to be very big in size. Number two is this velocity, that is the speed with which the data is being generated. And number two, velocity. Then number three is the variety, different type of data. Usually, traditional data involves text, numbers, and some special characters. But big data even involves videos, images, audio with text. So it is actually a variety of different types of data. So those three V's, the volume, the velocity, and the variety. So those are the things that makes a data a big data. You might have been collecting data for a very long time and it's very voluminous. That doesn't make it a big data if it is structured. It doesn't make it a big data. Example of big data are data generated on social media by traffic, by users. Then traffic alerts, weather alerts, those are big data. Those are big data. You can imagine the number of information generated on Twitter per hour. So those are big data. Now, machine learning, what is machine learning? It's a subfield in artificial intelligence. I told you earlier that artificial intelligence works on the principle of machine learning. In machine learning, a system is developed to learn from the previous information that is being supplied to it, so it can make predictions and based on the data that has been fed into it. For example, a system is being fed with information of cats and dogs, pictures of cats and dogs, maybe 10 pictures of cats and dogs. Then next time an information is being presented to it to make decisions, maybe a cat or a dog is being presented to it to say, oh yeah, predict, what's this? Is it a cat or a dog? It will tell you, okay, this picture is having 80% picture of cats, maybe 20% picture of dog. So it's a cat. So that is how machine learning operates. Artificial intelligence is a broader field that encompasses machine learning. It refers to development of computer systems that perform tasks typically requiring human intelligence, like speech recognition, visual perception, decision-making, language understanding. Artificial intelligence actually can do that then. So next, I want to explain these diagrams, this particular diagram that tells us and give us an overview, a general overview of data science. Now, we've talked about data. In data science, we have two types of data, the traditional data and the big data. The traditional data are structured relational data. Don't forget, big data are determined by the volume, the velocity. Big data, yes, are determined by the volume, the velocity, and the varieties. The volume, the velocity, and the varieties. Don't forget about these three. So now, then in data science, there are basically three methods of data analysis: business intelligence, traditional method of data analysis, and machine learning. Now, at each point, I will define. So now, when do we need this data? When do we need each of these? When do we need traditional data? What is it that we want to work on data? So we need both traditional, be it traditional or big data. We need data at the beginning of our analysis. At the beginning of your analysis, you need data. So data is needed at the beginning of data analysis. Now, so when do you do business intelligence analysis on data? It is after the data have been gathered and organized, cleaned or whatever, then you now do a business intelligence analysis on it. So at what point do you do traditional data analysis or machine learning data analysis on data? It's after a business intelligence report have been created and discussed. Then you might want to know why this thing happened. Okay, why? Why do we have it this way? Yes, we had more sales in October. This analysis is showing that there are more sales in October and then November, October, November, and December. Okay, than the other months in the year. Traditional methods or machine learning methods is actually we're actually trying to find out why, what happened, why, so that if you know why, You will know what to do. You will know where to direct your efforts. Now, why do you need it? Why do you need traditional or big data? Data-driven decisions require well-organized and relevant raw data stored in a digital format. If we want to make a data-driven decision, we need data. There's nothing we do that. Now, why do we need business intelligence? We use data to create reports and dashboards to gain business insights, like I mentioned. Okay, from that you can say, okay, from your analysis, you're able to say, oh, we had more sales October to December. So we have been able to create with that a report and dashboards. Now, predictive, why do we need traditional method or machine learning for predictive analysis? We should be able to say, okay, the last 3 months of the year, there's usually an increase in our sales. So you can make prediction. So why we need these traditional methods of data analysis or machine learning is that we want to make predictive analysis. Now, in traditional method, you use statistical method, the advanced statistical method, the traditional statistical method, while in machine learning, you use artificial intelligence to predict behaviors and unprecedented ways. We move on. I want to assure you that at the end of this explanation of this diagram, you will be able to actually understand what data science is and make your decision to pursue data science. So, what techniques are involved in each of these? In big data, the techniques involved in traditional data, this is traditional data. The techniques involved is what are the pre-processing techniques that you need? You label your data, you clean your data, you deal with missing values, and then in big data, you do the same. You deal with missing values, you go through it, you do data wrangling. Now, in analysis, business intelligence analysis, you extract information and present it in the forms like KPI, metrics, reports, and dashboard. That's what you do in business intelligence analysis. While in traditional data analysis, traditional methods of data analysis, what you do is that you do a regression analysis. You check a relationship. You try to see if there are a relationship between one or two factors. You do clustering analysis, like factor analysis, time series analysis. While in machine learning, you do supervised learning, which involves deep learning, random forest, and neural networks. Those are the methods you use in machine learning. At what point, where do we make use of this? Where do we get this or make use of this? Traditional data, you can get that from customer data. I give an example, yes. Information of customers in bank. But big data, you can get it on social media or financial trading data. Then historical stock data are also traditional data. Now, for business intelligence, why do you need this? You need it for price optimization, inventory management. And then in traditional, you actually need this data for sales forecasting. In machine learning, you want to detect fraud. You want to be able to detect fraud. Now, what are the tools that we use? What are the tools? If you look across, you will see that there are common tools that run through. We have R everywhere. We have Microsoft Excel almost everywhere. except in those places that involve machine learning. Like big data, you cannot use Microsoft Excel for it, and then machine learning. If you look at all the software, the SQL, you make use of SQL also in those places where you can use Excel. You can also use SQL. For big data, SQL might not be very, very effective because SQL work on structured data. SQL is actually structured query language, so it cannot operate on data like big data that is not structured. Okay, so who are those? The careers that fit into this. In traditional data, I talked about data architect, the person who designs a database, the database engineer, the database administrator. These are the people who work here. At big data, we have big data architect, big data engineer. And then at business intelligence analysis, you need a BI analyst, a BI consultant, and BI developer. For traditional data analysis, you need a data scientist and data analyst. And for machine learning analysis, a data scientist also fits in here, then machine learning engineers. So you need to pick up a career. You can pick, if you can decide to pick up a career based on the skills that we mentioned earlier, the ones you have. You can start somewhere and then move and graduate. Now, data analysis process and the tools required. What are the processes involved in data analysis and what are the tools that we need? This will lead us to the tools that we need for data analysis. The first thing is that we want to define the business problem definition. Why are we trying to get data? What do we want to achieve by getting this data? All these questions are to be answered before we go for data collection. The next is that you now get your data. After getting your data, like I said, all might not be complete, so you now do data cleaning. After your data cleaning, what else do? You do data analysis. When you must have analyzed and gotten results, what do? You need to communicate your results in a way that everyone can understand it. Anyone who reads it can understand. That's a result communication. So data visualization. So your data analysis is not complete without data visualization. So business problem definition. This is the planning stage to determine why your data should be collected. So at inventory and data collection level, what are the software that you need? You might make use of Google. It depends on how sophisticated the data you need might be. But you might make use of Google Forms to collect your data. You might use Kobo Collect, Fedry Form, Asana Webflow. And then for data cleaning, Microsoft Excel is very good for us at data cleaning. Tableau, OpenRefine from Google, Panda from Python library, R and the Tidyverse from R libraries. They can help with data analysis, data cleaning. Next is data analysis. The type of data analysis that we want to do will actually determine what software we will use. If we are doing a predictive analysis, we have predictive analysis, prescriptive, descriptive, inferential, time series, cluster, and regression analysis. So it depends on which type of analysis we are doing. A predictive analysis tries to forecast, uses models and forecasting techniques to understand the future. So in this case, SPSS can do predictive analysis for us. RapidMiner, SAP predictive analytics can help out. Prescriptive analysis actually wants to know what will happen. As predictive analysis shows us what will happen, then predictive analysis tells us the story of how it will happen. So if you want to do a prescriptive analysis, similar software that helps in doing predictive analysis does prescriptive analysis too. If it's descriptive analysis, SPSS and Excel does that, like calculating measures of central tendencies, dispersions to describe data. Then SPSS help with that. Inferential statistics, inferential analysis, it uses statistical analysis plan and testing to make inferences about the population parameter, such as mean or proportion. T-test, F-test, ANOVA, all these are inferential analysis. So SPSS, Excel, and Stata can help. MATLAB, SAS can help. Time series analysis. The data collected over time can be used can be analyzed. So using Python, R, and MATLAB. Now I will be ending this class. I believe you've been able to have an overview of what data science is. What's next? The next thing to do is to get a skill on how best you can start. So how do you start? I am presenting to you some video tutorials that I have gathered on SPSS, Microsoft Excel, R, Tableau, SQL. All these, I have gathered them together and I am presenting them to you. So, if you need more, you can chat me up and I'll make the video materials available to you. Thank you very much for going through this lesson.